Hello, thank you for taking your time to watch this video. Today we'll be talking about potential carbon sinks for BC. The scientific community has unanimously accepted the reality of climate change and the threat that it poses for the planet and its inhabitants. Greenhouse gas emissions are the driving force behind the climate changes, and the ever-increasing emissions are causing record concentrations in the atmosphere. While nitrous oxide and methane concentrations are also problematic, the longevity and abundance of carbon dioxide in the atmosphere is currently the most serious concern. Climate scientists have long been able to correlate the concentrations of CO2 in the atmosphere to the change in global temperature. As more data becomes available through consistent and more accurate measurements, they've been able to create models predicting emission rates, trends, and corresponding temperature changes. If our annual emissions continue to increase as they have since the 1980s, these predictive models suggest that we can expect a 3 to 5 degree increase in global temperatures by the end of the century. Let's take a closer look at the emission projection leading to the temperature change of less than 2 degrees, which is the target specified in the Paris Agreement. If we take a look at this graph, simply reducing the rate of emissions will not be sufficient to ensure a temperature change well below 2 degrees. In order to meet these emission targets, not only do we need to ramp down emissions, but also employ special types of carbon capture and sequestration systems, categorized as negative emission technologies. Two such technologies receiving a great deal of attention worldwide are direct air capture and bioenergy with carbon capture and sequestration. Direct air capture, DAC, is a process by which air is processed and CO2 is removed using a capturing solution, then removed from the solution and concentrated. That concentrated CO2 can then be used in several different ways, including low carbon fuel production or permanent sequestration. Another option is bioenergy with carbon capture and sequestration, also known as BECCS. The primary idea behind BECCS is that as plants and vegetations grow, they absorb carbon from the atmosphere. If these plants were harvested and used for energy production in combination with carbon capture and sequestration, the resulting energy would be produced with negative carbon emissions. This benefit is twofold in that the carbon is absorbed by the plants during their growth and would never re-enter the atmosphere, and that biomass fuels could start displacing fuels with higher carbon intensities. In 2015, BC recorded a net emission profile of 61.6 million tons of CO2. The 2018 estimate is expected to be larger due to increasing population, transportation, and the built environment. It is expected that industry will contribute 35 million tons of CO2, that the built environment and transportation will contribute 35 million tons, and that land use change will account for just 500,000 tons of CO2, leading to a final value of 70.5 million tons of CO2 for 2018. Carbon Engineering is a BC-based company looking to commercialize direct air capture. The structure pictured here is Carbon Engineering's proposed commercial deployment that they hope to implement by 2021. Unfortunately, the isolation process requires massive amounts of heat, approximately 300 to 500 megawatts, which comes from burning of natural gas. But with the help of Carbon Engineering's clever co-capture system, the CO2 from the combustion is redirected through the system, and the entire process becomes essentially carbon-free. Based on BC emission rates, we would need to implement 71 Carbon Engineering direct air capture facilities in BC to offset our emissions. Considering the first half of the BECCS cycle, this function approximates the amount of carbon stored per hectare of temperate forest. A young and growing forest readily takes in and stores carbon dioxide, but as the forest matures, its ability to store more carbon is diminished. If we used BECCS to offset the 2018 emissions, BC would need to sustainably manage the hectares of additional forest given in this table. If this forest was harvested for energy production, it would produce approximately 142 petajoules of energy, roughly 12% of BC's 2015 demand. However, BECCS comes with its own issues, and there are concerns whether it's possible to balance the collected emissions with emissions associated with the land use change. Removing forested areas for quick-growing bioenergy plants reduces the net area of natural sinks. This issue of balance has sparked debate over the term negative emissions. If we are to avoid this issue, the forest must be managed sustainably. While carbon capture and sequestration is very important, currently there is very little incentive to do so from a business perspective. Hopefully, research and development combined with policy change will allow negative emission technologies to become more economically feasible and environmentally friendly. Thank you for listening.